everyone. Today I'm going to show you about the memory leak. That why is dynamically allocated memory. Dynamically allocated memory is very necessary. To be freed. Like there are, wait a second. Let me toggle. So there are three types of memories. Statically allocated memory, and dynamically allocated memory. Okay. So in statically allocated memory, what happens? So you can say that statically allocated memory, it is compiled, means it is allocated during the compiled time. And what about the dynamically allocated memory? Dynamically allocated memory is allocated during runtime. This is the major difference. And statically allocated memory is stored in stack, and it is deleted by itself only. Means the spaces speed up once the function has occurred, or the function the or once the function has occurred. Okay. And in case of dynamically allocated memory, it is needed to free up the memory by using delete for the array and the simple delete for the integers and the other for the integers. So there are various programs. One of them is hashtag include, writing the boilerplate first. Hashtag include string using namespace std in main. I don't know, I'm writing the first word first, second word first. And main return 0. Now how the memory is allocated during the runtime. Suppose it is func. I'm creating a function of func. Suppose it is this, I'm creating a function and I'm taking it in the form. Suppose there is in size. I've created a size variable. In this I'm taking the size. Now I'm creating an array for int I equals to 0, I greater than n, or I greater than size will be the chapter 3. So I'm taking the size. Before that, it's important to create the numbers. I'm creating the suppose creating an array in the form of pointer, int array equals to new int, and it would be a size. That much size only. Int array equals to new int size. Now for I equals to 0, I greater than size I plus plus. I'm going to print. Suppose I am taking int one more variable x equals to 100. I'm going to print cout array of x. Okay, cout not array of x, it will be array of I. And I'm declaring that array of I will be equals to x, and every time the x is going to increase by 1. So it will be x plus plus. Now I'm calling this one. I'm not passing any kind of size or all because it is dynamically reallocated memory. For before the execution, it is not necessary to declare the size of the array. Let's run this code. Suppose I enter the size as 4. Wait a second. What the mistake over here? Array of 5 equals to x. Now x plus plus. What we found over here? Okay. Okay. There's nothing any kind of space needs to be filled. Now the table must be suppose I enter the size as 4. 100, 101, 102, 103. So this is how the memory is allocated dynamically during the runtime. And in the stack kind of memory, so what the difference is going to be created in the stack memory. First of all, main is called, and then from the function is called, from the main. And now what will happen? And now after the execution of the function, now after the execution of the function, what will happen? Once the function will be executed, the stack memory is going to be freed. And in case of is going to be filled with it. And here in the heap memory, the heap which is responsible for allocating dynamically allocated memory. So in the heap memory, what will happen? That first of all, the size is a size I'm taking during runtime only from the user, and I'm creating the memory inside the heap. So now after the function has been called, it has returned like the function has been performed. Now there's nothing to perform. So what will happen? That function and name both entire memory is going to be free from here. Entire memory is going to be free from here. So once the entire memory is going to be free from here, but in the heap still which would be having the following data, the following data stored. Okay, the following data is still gonna to be stored over here. Now, as a good programmer, it's very necessary that you, after doing all these things, you delete the memory. You have to delete the allocated memory. Let's see what is showing down over here. Ever special primary function before token. Now, means delete keyword is used for filling up the memory. That means why it is not accepting this. This was all about statically allocated memory and dynamically allocated memory. 1 second. So alright, that delete was not working because you have to specify that what you are deleting. Like delete, I have created an array and you to specify it. Now it will be not showing any more error. Suppose I have created the pointer towards 106, but after this stack memory is going to be deleted and the memory is going to be freed by itself. But in the case of pointers, what I have to, sorry, in the case of the heap memory which is then created, it needs to be deleted explicitly. So this was also a tutorial, and even we can create a pointer return type like void func, like if I'm creating in, okay, in func start. Wait a second. So it will be in size, same size, and just 100. In array, or we would simply say int array, and there is no need to write this. New int array, new int. Remove this even. No need to write these options. Or we can say that's return array needs to be declared over which kind of hierarchy. Showing star functions inside C. The index I have created 100 or they need to for index over in star array is int and then I delete the array, return the array. I'm going to call the function with int pointer x separate I'm creating which is responsible for storing the value of this after in pointer x we will see out pointer I have to pointer x and then enter and so it's simply going to be in pointer goes to 12 suppose I created int equals to new and saying and what will be stored in the array. Suppose it is now to be 1200. There's no need to put these things tags and all. What is wrong over here? Return array. Int array equals to 1200. Pointer array equals to 1200. So each array return array. I don't have to use this. That's fine. So say 1200. You don't have to use it there. Okay. This is all for today. Just all for today. I show you all from memory and how they and um, memory and how the start memory. This was all for today. Thank you and keep learning.